Hi everyone, I'm Don Garnier. I'm a co-founder at a company called Blecon. We connect Bluetooth devices to the cloud, which is why we're spending a lot of time thinking about Bluetooth and Zephyr and how to test it. And to give you a bit of background, let's imagine, no, I think that's meant to be me, by the way. Let's imagine you're on your way to sign up a very important customer, right? You've built a Bluetooth device, and you think that this deal could make or break your company. And you're feeling pretty confident, right? Because you've tested your Bluetooth product on your desk, and it works pretty well. And the caveat is that that customer, they don't want to buy one device from you. They probably want to buy 1,000 or 10,000 devices, maybe more. And the question is, if you sign that deal, will you be able to ship those devices with confidence? Will the thing work? Well, the sad answer is probably not, right? Because you're like fighting with probabilities at the end of the day. So your Bluetooth Zephyr device, maybe there's a bug that will show up in 1% of the cases, and that's pretty small, right? But once you're scaling up to 10,000 devices, that's already 100 devices not working properly. And also, your customer is probably going to be using your devices in an environment which looks very different to what your average office environment looks like. So expect a lot of support calls, right? So this is what this talk is about. What are the things you can do earlier on so that you can walk into that meeting with more confidence, building that Zephyr Bluetooth product and knowing that it will work in many, 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 many cases as expected. And in practice, it means how do you go from like more basic testing, like with a dev board maybe, to something a bit more complex, like a test farm with like hundreds of devices, or can you leverage simulation and things like that? So I'm here with like two colleagues, like Nick and Adam are in the room as well. And Nick's had a great talk yesterday about how we leverage white label hardware to build embedded Linux products. So you can talk about that with him if you catch him. And Adam is the person in the team who designed the testbed I'll talk about. So any testbed related questions you can grab in the hallway. So very briefly, just to give some context on what we're building, so it's relevant to, it gives you the context, so it's not talk about Blecon or anything like that, but just knowing what we do is, will frame why we're doing the testing, right, and what we're testing. So basically, the companies who use our product, they want to get data from devices, which are running Zephyr, so they integrate our software, and then that software lets them connect connect those devices to the cloud with infrastructure that's Bluetooth, so it's already there, so mobile phones and Linux gateways and things like that. So that sort of frames the kind of thing we're testing, and we're on the device side, we're already leveraging Zephyr as the platform, our platform of choice. And in our talk, I'll just focus, when I say Bluetooth testing, like I already mean like Bluetooth testing above HCI, so not really, you know, it's not about developing a Bluetooth link layer, it's more about how do you use Bluetooth efficiently in Zephyr and make sure that your Bluetooth device will work as expected. So why is Bluetooth testing, why is it hard? Right? If it was easy, I probably wouldn't be there talking about it, and we wouldn't have spent a lot of time in the team thinking about how we test our device software, right? Well, it's hard because you never, when you test a Bluetooth device, you're not testing it in isolation, right? It's part of a system. It's your device talking to a phone, right? And that phone maybe is an iOS phone, or maybe it's an Android phone. And if it's an Android phone, that really depends on which which Android version is running on the phone, and also which hardware and which vendor stack. And so there's a lot of like Bluetooth is amazing because it's everywhere, but because it's everywhere, that means your testing surface is huge, right? Potentially. Especially Android is quite tricky if you've had experience with that. But maybe you want to have like PC apps as well, right? Or embedded Linux software communicating with your Zephyr Bluetooth device. So what can you do to test this system, right? And in this talk, we'll talk about different strategies you can have, like starting from like tests you can run like at the start, like to help you make decisions about how you're going to build the software, to things where maybe you're going to start automating some of that testing, and finally we'll touch about what you could do to potentially get information even from when your device is in production, because you can't possibly test for everything. So knowing about those bugs that might still slip through the net can be interesting too. And as you move like from left to right, of course the investments are the return on investment, I guess, in terms of number of bugs you'll catch will diminish, but it might still be required to go pretty far to the right to achieve like what a production system should look like. So Bluetooth is because it's so pervasive, there's also a lot of testing and ecosystem around Bluetooth testing. So you can do quite a lot of clever stuff, right? You can test your device in an RF chamber. You can use sniffers, for more from open source ones to commercial sniffers. You have tooling in Linux. You can enable HCI tracing on Zephyr, and then get an HCI dump of what's happening on HCI. And that's not unique to Zephyr, by the way. Most platforms will let you sort of get an HCI log, which can be super useful in the early days to understand how your system is behaving. And I don't want to dismiss that, because that's super important. Do these kind of things in the early days. You're not going to put it probably not an RF chamber in CI, but doing those things once in a while to understand your system can be super valuable. And for instance, in our case, in the early days, we did some of those experiments, right? That stuff we'll probably never put in an automated, in a CI or something like that. But for instance, one question we had at the start is, should we use GATT or L2CAP to build a sort of connection and send data between the gateways and the devices? And so we did different measurements, and we discovered things that we didn't know about. For instance, if you look at for a device that's advertising every 100 milliseconds, an Android phone seemed to connect to it pretty much instantly, but iOS was far less eager and would wait maybe 10 advertisements before connecting to the device. And then you have weird things where if you look at the second column, bare open is when can I begin to send data? So for instance, if you're using GATT, that means after you've discovered all characteristics from your service and registered any notifications and things like that. And for L2CAP, is my L2CAP channel connected? And we noticed some very weird, I don't know if it's weird, but striking differences with Android. If you're using GATT on Android, it takes a lot of time because Android is discovering everything possible, and that takes a lot of time before you're able to send data. Conversely, L2CAP on Android, the connection is pretty much instantaneous. And then iOS is a bit in the middle because it's doing a lot of stuff in the background and you don't really know what the OS is doing, things with your device, trying different things, but you have less control. But it's kind of in between, there's less of a performance difference. But that was very useful because we're okay, L2CAP seems interesting, right? Especially on Android. Another thing we did quite early on, as a point test, is we're trying to figure out if we should support coded PHY or not, or just 1 meg PHY. So we put some test Zephyr devices across our office at the time, And we had a second Zephyr board, like another board, like running Zephyr, which was sort of scanning for advertisement on those two files. And we sort of wheeled it around on a desk chair and took some measurements at different points in the office. And then we could sort of see like how many advertising packets we would receive, right? And compare coded file versus 1 meg. In the end, we decided like to ignore coded file, but like for your product, it might like make perfect sense. But without doing some basic testing, because like there's a lot of like marketing out there about benefits of each Bluetooth feature, but if you're not testing it in an environment which represents the environment in which your product will be used, then that's not as useful. So knowing all of that, like we did like some point characterization. We need some like testing on desk. Like what did we do in terms of more automated, reproducible testing? Well, the first thing we decided is trying to test everything which was not Bluetooth related, because that's much easier, right? So if you try to eliminate a whole class of bugs which have nothing to do with Bluetooth, and I know it sounds a bit obvious, but making that conscious choice does make a difference. So we really try to isolate our software blocks and like really test them separately if we didn't have to like hook them up to some kind of Bluetooth like hardware. So to enable that, we just added like some interfaces in our like software stack, and you could do that in your application. That's not specific to us. So we created like a little advertiser abstraction and a little bearer abstraction. The advertiser mimics like an advertising, like the more like gap part of the stack, and the bearer abstraction is more for connections, right? And so we really tried that divide and conquer approach. So we really unit tested all of our non-Bluetooth code above those two layers. And then the other thing we did is that we created that sort of mock in-memory implementation of those advertising and bearer layers, which meant that we could run a bunch of tests just on like a Linux machine without touching anything Bluetooth. So it was quite cool, because we do catch quite a lot of bugs just with that. And then of course we did some Bluetooth testing, right? Like it's not like that was not bait and switch. We're going to talk about Bluetooth. So yeah, from that approach, like the benefits were like we're able to catch a lot of bugs early on. We could benefit from native tooling, like once you've coded a bug, you could rerun your code with Valgrind and stuff like that. And if it's a memory bug, for instance, like super easy to do that and super quick to get those fixed. The soft trade-off is that you do pay a bit of abstraction cost for adding those extra thin interface layers. But we believe it's worth it. So then, like in terms of actual Bluetooth testing, the next step we took is actually running tests on actual Bluetooth boards. So what we did is deployed some Raspberry Pis, and they're running Balena, which lets us run Docker containers on those Raspberry Pis, and that's super useful because we can have encode deploy basically the software we need to flash those devices, run the tests. And the thing that's included in that image as well is a GitHub Actions runner. So those integrate within our GitHub Actions workflows and our CI. And in practice, that means that within our sort of CI workflows in GitHub, we can just list a bunch of tests that will run against those boards. And that's kind of like a simplified testing of what our the hardware in the loop testing infrastructure looks like. So we have a selection of boards, each connected to Raspberry Pi, and a selection of phones and PCs and our embedded Linux target. And then because we have a cloud thing, of course, there's also a cloud aspect of testing as well. And a typical test will sort of look like that. So we have the scripted test running on the Raspberry Pi, and it's orchestrated from there. We flash the test image onto the board, and then we can send commands and data to exercise the test onto the board, like sometimes using the Zephyr shell, for instance, or by parsing the text output. And then same on the cloud side. And the one, I guess the one sort of trick we have is that the cloud can then tell a specific phone, hey, you should connect to that device, and then exchange some data. And then we can get data back and then make sure that the test run correctly. So what are the sort of like benefits and also limitations? Like still pretty quick to test those things. Like we can run a subset of tests on every PR, which is very valuable when you're developing quite quickly. And we can run like the sort of high risk stuff. Like so, for instance, can we run an OTA type workflow? And that really lets us make sure that we like if that software gets shipped, there's a get out of jail free card. If everything else is broken, you can OTA out of it still. That's not the worst outcome. And we validate like like the sort of examples we have and like some reference scenarios. So it's fast enough, but we run more comprehensive testing and more like nightlies. The limitation is that it's still a pretty small subset of scenarios. It doesn't last very long, and it's like only on a few targets. So it ends up being mostly happy path testing. You're not going to catch that odd bug that happens once in a million times. So that leads me to the sort of next thing we did, which is rolling out a more comprehensive test bed. And what triggered that is basically once we had like some customers who reached like, like they started using a certain number of devices and reporting those bugs we had never seen before. So we bought a lot of Nordic dongles and a few USB hubs, and we built like this kind of like dedicated, this specific dedicated firmware, which was meant to exercise different parts of our system. And the goal was to sort of replicate a more typical customer deployment with the similar range of devices that they might find. Like one little random sort of tip, something we hadn't noticed first, like we wanted to like connect all of those dongles to a single PC or a single computer, and your USB, like most like USB hardware, is actually pretty limited in terms of the number of devices you can connect to it. So we learned that a bit the hard way, I guess. The Raspberry Pi 5 seems to be pretty good at handling a lot of devices. So we're quite hopeful we'll be able to simplify that a little bit. But yeah, so we have like all those devices. We update like a firmware nightly from main, and those tests run for at least that firmware is meant to run for a day at least, so we get much more coverage. And in terms of like visualizing what's going on, so those devices, they're like sort of pinging a backend like regularly basically over Bluetooth, going through various gateways. And if they can't send data for a while for some reason, then those little happy faces turn very sad. And everyone can see it in the office, so we set up a screen, and that way like the other our marketing folks and our non-engineering part of the team, they see it and they're like, engineering, you have to fix that pronto, because we have we can't have those angry faces staring at us. So it's a good incentive to keep the team honest as well. So what does that sort of test firmware do? It's meant to run for at least a day, as I said, and there's sort of two channels that we have that goes over Bluetooth. The first channel is to our sort of in-own testbed visualization orchestration app, from which the device can get some configuration about, for instance, how often should it try and send data, how much data should it try to send, things like that. And the other way, every time the device does connect, it sends a bunch of metrics they can measure and see if something's going wrong, quite obviously. The second channel we have is a channel to memfault that we use to collect core dumps, which is super useful because if those devices crash, or if something like happens and there's an error, then we can see what's going on. And we use memfold to deliver those over-the-air updates as well. So what's the objective there? Like, it's really about finding those lower probability bugs. So we expanded our the number of dice were rolling by running those tests for at least 24 hours, and also expanding the number of devices, right, to over 100. And in terms of making sure we can surface issues when they happen, well, we've taken a pretty radical approach. Any error, be it small or big, like we make the device crash, and that lets us trigger a core dump, and that's very visible to everyone, right? We get emails and stuff, like you can't ignore it. And then in terms of more performance or non-functional metrics, we can measure those using our own testbed backend. And once again, we can visualize if something is abnormal, right? If there's a regression in terms of performance. That's an example of what memfold gives us in the UI. We can sort of compare two versions side by side, and then we see if, okay, has there been a performance regression, right? Is that new version more crashy, if you wish? And that's very obvious if there's something very different happening. And that's more like a core dump view, and that is super useful because then, once you get that core dump view, you can reproduce it locally on a device. So you can sort of see what happened. You get the logs that precede the crash, and then you can reproduce it. But also, once you fix the bug, or you think you've fixed the bug, then the next day you can check that the crash hasn't happened again, right? So once again, it keeps you honest, and you can only close the bug once you're the bug report once you've made sure that you've actually fixed it. And then this is the type of some metrics you can get. I'm not going to go into detail, but from those we can derive some performance metrics, especially related to how devices perform against various basically phones or PCs and things like that. So if there's something abnormal, we'll see it as well in that dashboard. So I wanted to sort of show some examples of actual bug with code using that approach. This is something where we saw that a device sort of stopped responding. It stopped sending data, but it didn't crash. So what we did was just connected the USB hub, which was connected to that device, your laptop, and connected to the Zephyr shell, and made it crash like that. You can there's a command that makes it issue a core dump. And then we could sort of see where the device was stuck. And basically, we saw that an L2CAP buffer allocation never completed. And basically, in that case, there was I think, yeah, it's some kind of race condition where we're trying to allocate data on a channel which had already been closed, and maybe the phone had disconnected before the device realized that it was disconnected, something like that. And so we're able to fix that and verify that it had been fixed. This is a separate issue we found, something that was initially reported by a customer. Some devices were able to send data but never received a response for some reason. And so we were able to add a metric that sort of to help
visualize the sort of number of messages sent. And we could see that at some point the device couldn't complete the previous the previous exchange, so it was getting stuck and trying to send the same thing over and over again. And this one was more of a flow control issue. It was a code path under which a flow control token wasn't given back or something like that. And we're able to debug that and fix it and verify that it was fixed. This is another L2CAP memory related one. We saw that there was a memory exhaustion bug, and I was in this case, under a specific circumstance like the buffer was leaked, and the tricky one with this one is that because the leak wasn't happening that often and only under like specific conditions, you wouldn't see the bug for quite a while until you had exhausted your memory. So that was, but we're able to catch it using the metrics and the crash dump approach. And then this one is not our bug, but we faced it. Android changed their Bluetooth stack in Android 13 with, and they, well, I'm not going to be able to pronounce that, like to something called Gabble Dorsch, and it's difficult to pronounce. But like the issue is that obviously there were like some stability issues, and what like basically the way it would present itself is that on the phone side you would. Everything seemed to work fine. The stack was still responding, yes, 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 but it would never send you any advertising packets anymore after a while. And so you wouldn't be able to connect to devices. And so just like shows you that sometimes it's not your bug, right? And you have to be able to, have strategies to deal with those things that are not under your control. And that's kind of the transition to my next topic. And the things we're working on now to try and like mitigate those more system bugs, right? And the first thing we're looking at is integrating open telemetry across our whole stack from server to gateways, so apps and embedded Linux gateway, but also down to the Zephyr device level. So it's a bit experimental at the moment, but we're hoping we can get more insights into, you know, like how the Bluetooth connection sort of travels across the stack, and see if there's anything weird happening. This one is an example of our Linux hotspot connecting to a device, and you can sort of see like different phases of like the connection and like data being exchanged and things like that. The strategy for now will be to have like some tracing for Zephyr devices using over USB, and then in the future maybe we might look at having some tracing in band as well, so we could like get information from things in production as well. I think something which is great about open telemetry, which feels like so far from the Zephyr world, but that actually is a super valuable thing because it's standard, and then everyone can use that telemetry standard, and you can have traces that propagate between through your stack using different operating systems, using different languages, and you can get that sort of high-level view, and then get those with the right tools, create the right correlations between events and bugs and things like that. So very powerful, but for us it's still like the early days, but we think it's going to be very promising. The other thing I wanted to highlight is more around the simulation side of things. There's that great board in Zephyr, which is actually not a board, which is a POSIX emulation layer for Zephyr, which is called, so it's called Native Sim. I don't know if you've come across that, but what's very cool with this, when you're doing Bluetooth, building a Bluetooth device, is that it lets you connect to a virtual Bluetooth controller. And that virtual Bluetooth controller can be exposed over any TCP server, which means you can like quite easily map it to an actual controller, but you can also hook it up to a purely virtual controller, which is emulated in software. And the two main projects we've looked at, which are quite interesting, are that Google Bumble controller, which seems promising, but still quite early stage. I don't think it's super mature yet. We use a lot of extended advertising features, for instance, and they're all, last time I checked, they were all like living in an experimental branch, so it didn't really work for us. But root canal comes from the Android testing world, like testing of Android hardware. And this one's much more mature. And it gives you like that virtual controller functionality. What's really exciting about that is that you can do, well, first, like, you know, purely local development, not involving hardware, like just on your desk, but also that means you can do reproducible testing in CI, which is very exciting to us. And why is it very, very cool is that you can hook up to that controller, you can hook up your Zephyr application, but also an Android emulator or a Linux app, and build your like mini network, like root canal operates as your sort of virtual Faraday cage, if you wish, and the whole thing is quite easy to script and also very, very quick to execute. The other use we're looking at for this tooling is maybe doing some form of load testing, performance or load testing. So what happens, you have like, I don't know, like 10,000 devices, like a version of that test bed with 10,000 devices. That seems interesting, but the limitation we found is that most work on root canal is scheduled on the same thread. So at some point, like once you've exceeded like a few hundred devices and connected them to root canal, like it starts being a bit tricky, and you can't really scale it easily across cores or anything like that. So that's something if we're going to do that, we would need to contribute some changes upstream. So maybe, but that could be quite interesting, because at some point, like testbed with 10,000 devices, that seems like that starts being a bit difficult. You need a room for it, which we don't necessarily have. So in conclusion, I guess the sort of lessons we've learned when doing this is, a divide and conquer approach really pays off. If you've really validated your non-Bluetooth code, your hardware-independent code, then everything is a little bit easier afterwards. So really, like, try and isolate your like little blocks, and then do like unit or integration testing before you get to the hard stuff, right? And I guess when I say first things first, like start with the test which will catch the most bugs, right? And also start with point characterization. I'm not saying go straight to automation, right? Like first do a mock flow on your desk for what you want to be able to test automatically. Because Bluetooth is great. You have like a lot of tools out there. Find the right tools, and some people have done already a lot of work around that you can leverage. And my last point is, focus on what's important. You could do a lot of things, and usually, like the return on investment with every test or the new infrastructure you add will tend to diminish. But that for some, like, there might still be the right choice, because you really need to catch like 99.99% of the bugs or something like that, right? So that's evaluate the trade-offs and select the strategy which will give you the most bang for your buck at the end of the day. That's it. I think we have a bit of time for question. Thanks a lot. Yes?
I have a testing related question about your testing approach. So at least from what I saw when you were showing on hardware, do you run like defined scenarios or like test use of given tests that you check what kind of functionality is verified and whatnot? Or is it more like you just run a big setup and monitor if it's going to break it when? So are you running like a dedicated, like, I don't know, regression testing that you're validating each requirement or whatever test scenarios you have? Or it's more like just run and see like non-functional, like stress and performance?
So the question was, do we run more like test scenarios, or are we?
From functional point of view or from non-functional?
Yeah. We run a lot of like regression tests or like scenarios on the first hardware in the loop type tests that we have, where we can quite easily like deploy the firmware and then like run test script and like validate that. In terms of what's running on the test bed, it's more optimized so that we can run it for a long period of time. So we don't want to change the behavior of the system as it goes. And that sort of test scenario is more designed to stress the system. So it's more like of a long-running stress test. And we try and mimic like all the sort of more extreme things that our customers might do. Yeah.
Okay, thank you.
Yes? Mm.
and still with radio communication, you always have like missing packets at some point, so your test will fail. How do you handle that?
So I guess before we, because we operate above HCI, like there's some level of that already handled within the software itself that will retry to retransmit if a packet was lost and things like that. But you're right. I think that's a limitation we've started seeing in some cases where, like, sounds stupid, but one day we get a delivery of 500 devices, and so suddenly we have 500 more Bluetooth devices shouting in the room, right? And that changes some behaviors. So we're gonna move some of those tests, which maybe are being more flaky, to like a Faraday cage, basically. We haven't had that much of an issue so far with that because there's more like retry behavior that might be baked into the software itself. But we want to. That's more of an issue on the sort of non-functional side of things, where we can see performance changes, and we want that to be more reproducible. And we think that the simulation stuff can help with that as well, because that's very reproducible by nature of not being subject to any type of environmental interference. Yes?
Can you describe maybe a little bit how your releasing process would look like? Describe the setups and techniques that are available. Is there some kind of testing plan or something for releasing?
So we try to keep like our main branch green, and I'm not saying that's always the case, right? But like the objective is to be able to release at any time, because we sometimes have to release quite often. And so the release process today, like, just make sure that the main is green, and like the selected tests we have run successfully, and then the test bed was able to run for a long enough period of time on that specific commit to make sure we've caught those like lower probability bugs. And then we basically just run a test, like not a test, like a release workflow on GitHub, and that just generates artifacts based on that main version. But we're trying to bring that testing earlier in the process so that we can release at any time. Because in the past we had a more like point releasing approach, and that was quite disruptive.
So there's no manual testing involved?
We try not to. And I'm not saying that sometimes, like if you introduce like a new functionality which we're less confident about, and for a specific customer, like we'll test it on desk. But the aim is to really, like for next time, we try and automate it and put it in CI, right? Yes.
Just to make sure that I correctly understood it, the test setup you showed with the many Nordic dongles. What was the system under test there? Was it your Blecon stack, or was it the application on top of that?
It's the Blecon stack, right? Which is like a library that sits on top of it's like a Bluetooth profile, if you wish. And of course, like we couple that with testing the corresponding mobile apps. So we do get sometimes some failures coming from the mobile app side of things through the use of the testbed.
But was on the other side, was then also same amount of mobile devices?
No, we don't have like as many mobile devices. I think it's because the sort of typical network topology we have is one mobile phone connecting to maybe 100 devices or 500 devices, or a Linux gateway. So there's one too many. So on the mobile phone side of things, we try more to have a representative like subset. It's impossible to have all the Android phones in the world, so we pick like some reference ones. But yeah, we don't have like that many in absolute numbers. Cool. I think that's we're out of time. But yeah, thanks everyone.